All right, so like I said earlier, there are many different techniques for integration, and one of the techniques that we will be talking about in today's class is integration by parts, in short IBP. Okay, so the objective for today's lesson is you will be able to find the antiderivative or integration using the method called integration by parts, and then know when to use tabular method for IBP. So there are some functions for which integration is a little bit messy. In that case, I will allow you to use the table, the formula list. I will provide you the list of formula, and you can use that list to find the integration, okay? So first of all, integration by parts. Here is the formula. Integration u dv equals ub minus v du. You need to memorize this formula, okay? Integration u dv equals u dot v minus integration v du. And one of the most important skill is that you need to know which factor will be u and which factor will be dv. Choice of u and dv are extremely important. The right choice of u and right choice of dv is extremely important. Otherwise, we cannot evaluate the integral. We'll see that example later. But let us look at the formula, how this formula is derived, okay? Recall from your Calculus 1, Math 104, if you are given a function, let's say y equals u dot v, it's a product, and in case of derivative, you use product rule, right? And the product rule is this: derivative of u dot v is u dv over dx plus v du over dx. You know that. Now let us rearrange the term. Let us do a little bit of a manipulation here. So using high school algebra, you can put this and you bring this side. So that's going to give you d over dx u dot v minus v du over dx. And now if you integrate both sides, okay, when you integrate, remember the integration and dx always comes together, integration and dx, whatever the function is there. So if I integrate both sides, so I'm gonna put integration, sine of integration and dx, here also sine of integration and dx, and same thing here. Now what I got here is integration of u dv. So I cancel that dx, I got u dv equals this dx cancel out. Now remember this du dot v. So the derivative of uv and antiderivative. So derivative and antiderivative becomes just this, okay? So derivative and antiderivative will be simply u dot v. And this guy, you got v d, you can cancel that dx. So you're going to get u dot v minus integration v du. So that's how the formula is developed. Okay, the formula is coming from the product rule of derivative. Now, tips on using integration by parts. In general, substitution rule is much easier, and the antiderivative, the basic formula, is easier. So first, try to use the basic antiderivative formula. If that doesn't work, then try to use substitution rule. And if substitution rule doesn't work, then think about integration by parts. Okay. The question here is, let's look at example 1. Remember, I told you that correct choice of u and dv is extremely important. And we'll see that in a minute. So in this case, to use IBP, remember here, there are two functions given. This is your u, and the remaining is, you can write this as dv. Okay? It's the product of two functions. So In this case, what I do is, let us suppose that u equals x and dv equals e to the x dx. Then you leave two steps here. Step 1, step 2, leave 2 steps. So let me copy that questions now as it is, x e to the x dx. Well, let me use the formula. The formula is that u dot dv equals u dot v minus integration v du. Okay, that's the formula. First, I suggest copy the formula. Now, let us substitute the value. U means x. Let us substitute that. Okay, we suppose u to be x, so I just want to substitute this here, right there. Now v, what is v? We don't know. What we know is we know dv, but we don't know v. How can you get that? Well, what you can do is integrate both sides in this case. Integrating both sides, you're going to get dv equals integration e to the x dx. So this gives me dv is v. Okay, derivative and integration, they just, neutralize, they cancel. So remaining is v. You know that integration of dx is x plus c, but remember, I don't write c constant here because we're going to write that constant of integration at the end. I don't want to make your life difficult by putting c there, c1 there, c2 there, and all this. No. Okay, we just play around with this. We find the integration without the constant of integration c, and we just put the integration, the constant of integration c at the end. So this gives me v equals integration of e to the x. You already know that ex. Don't write c. Okay, so u is x, v is e to the x. Let me just copy that now. Now integration v means e to the x, du. We don't know what is du. We know u, but can we find du? Well, yes, we can find easily. You differentiate that because we need it, so we need to find it. So du over dx equals 1. And this gives you du equals dx, right? So du equals dx. Now x e to the x, oh, there is minus sign. Let me just copy that. Minus, now you can tell me what is the integration of that, right? It's pretty easy, which is e to the x, and just write c at the end, like I said earlier, and that will be your answer. So that means integration x e to the x dx is this. Any question? Okay.
No, Professor.
Now the question is, what happens, if this is x e to the x dx, what happens if I write this, this integral as e to the x dx, and if I suppose u equals ex and dv equals x dx, does it work? No, it doesn't work. The idea here is that, here is the idea. In general, you try to choose u and dv such that du is simpler than u when you differentiate, and dv is easy to integrate. Let's try this example too. Okay, let's do a little bit, experiment here. Let me suppose, let us suppose that, because remember, I can do this as u equals let's say u equals x ln x. I can write this as 1 times x ln x dx. Let us suppose that u equals 1 and dv equals x ln x dx. Okay, let's try this way just for fun. What happens? Then in this case, your du over dx is 0. And if you want to do the, remember here, what we need to do is, for u, we have to find the derivative. For dv, we need to find the integration. That's what we have seen in example 1. So if I do the integration, what do I get? It's the same questions, right? It's not going to help us. So this choice is wrong. It doesn't work. Let's try. Let us suppose that u equals x ln x. Okay, I want to suppose the whole thing as u, and then my dv is, let's say, dx. Then what happens? Let's look at that. So we need to find the derivative. It's going to be du over dx. And if you find the derivative using the product rule, you're going to get, what do you get? Product rule. So product rule will be copy the first, find the derivative of the second. Remember the derivative product rule, using product rule, for that. So u dot v, or you can say f of x dot g of x equals, you copy the f of x, find the derivative of that, plus find the derivative of that and copy g of x, right? That's the derivative product rule. So if I use the product rule there, so what do I get? Let's see. Du over dx is going to be, I copy the first, find the derivative of the second, which is 1 over x, plus copy the second and find the derivative of the first, which is 1. So that's what I'm going to get. So that means du equals, this cancel out, you're going to get 1 plus ln x dx. And if I do the integration here, so integration of dv, integration of dx, so you're going to get v equals x. All right, now if I want to use the integration by parts, what happens? Let's see. So the formula IBP is, integration of u dv equals uv minus integration v du. So that's the formula. Let me substitute the value. So u means x ln x, dv means dx, equals u means x ln x, dot v is x, minus integration v is x, and du is what? Du is 1 plus ln x dx, right? If I substitute the value, substituting value of u and v, that's what we're going to get. If I simplify that, I'm going to get x squared ln x minus, this guy will be x plus x ln x dx. See here, we started with just x ln x. Now this integral is getting bigger and bigger. It's getting more complicated. We wanted to solve it. We wanted to simplify it. And we notice that it's not getting simplified. It's getting, complicated. So this choice is also wrong. So this method doesn't work. So the choice of u equals x ln x is not going to work. Now let's try another way. Attempt 3. Okay, hopefully this third attempt will work. Let us suppose that u equals ln x and dv equals the remaining. What is the question again? Let me just copy the question. So the question is x ln x dx. So that is the question. So what I want to suppose is, I want to suppose, because I can write this as ln x and x dx. So I want to suppose that to be u and this one to be dv, and let's see what happens. So u equals ln x, dv equals x dx. Then in this case, your derivative du over dx is going to be, remember, for u, always find the derivative. It is 1 over x. So du equals 1 over x dx. Now, if you do the integration on this side, so what you're going to get is v equals x squared over 2. Okay, like I said earlier, don't write plus c. Don't make your life difficult by writing c here and here, because at the end of the day, we're going to write that c at the end. Okay, now let's see what happens. So the formula IBP, the formula is integration u dv equals uv minus integration v du. So let's plug in the value. Integration u means, you see here, ln x, dv is x dx equals u is ln x and dv is x. Oh, b is not x. v is x squared over 2. You see, v is x squared over 2 minus integration v is x squared over 2, and du is, you see here, which is 1 over x dx. So this can be written as x ln x dx equals, this will be x squared over 2 ln x minus 1 over 2. I want to write that outside. And x squared and x 1 power cancel out. So you're going to get x dx. So this gives me x squared over 2 ln x minus 1 over 2. And you already know how to find the antiderivative of that, of this term, which is x squared over 2 plus c. That's it. Okay, so now your final answer, this looks a little ugly, so you can beautify it writing this way, ln x minus x squared over 4 plus c. That is your answer. Okay, any question? So if you don't have any questions, I have a questions for you. The question is this: how do we know which one go for u and which one go for dv? So which one we choose for u and which one we choose for dv? How do we know that? Do we need to do this trial and error method all the time? If that is the case, life is really complicated, isn't it? It's going to be very time consuming. For one question, you see, I've tried 3 times, but you don't have to do that. So I'm going to give you some tips, and with the help of that tips, you can figure out which one will be your u and which one will be your dv. Okay, for example, by the way, this technique is not given in our textbook, the textbook that we have used, but I find this really helpful. Okay, the rule that I call is Liat. Okay, the Liat, what does that mean? Liat. L represent the logarithmic function. I represent the inverse trigonometric functions. For example, tan inverse x, sine inverse x, cos inverse x, those kind of function. But we don't use that inverse trigonometric functions in this course that much. But anyway, A represent algebraic function like x squared, 3x to the power 50, that kind of functions. T represent trigonometric functions, which is sine x, cosine x, tan x, etc. And E represent exponential function. Okay, e to the x, 2 to the power x, something like that. Now, what that rule tells us is that, you know, according to this rule, whichever functions comes first, suppose that to be U. You know, U and V, in English alphabet, U comes first, right? In English alphabet, U comes first. So in this rule, whichever functions comes first, then choose that to be U. For example, in this case, remember how I choose this is, you know, I notice that this is my algebraic function. Okay, X is my algebraic function. This is my exponential function. So I check this in my head, Liate, and then I see that A comes first, algebraic comes first, therefore this is my U. E comes later. So whatever is remaining, that will be my V or dV. Okay? And this one, I did, you know, I did this by 3 method just to show you that how important it is to choose U and V correctly. But from now onwards, what you do is, this is your algebraic function. X is your algebraic function. Just denote that by A. And this is your logarithmic function. Now write this rule, Liate, Liat. Now which comes first? L comes first, right? In this rule, you see L comes first. L comes before A. Therefore, your U must be log X. You know, in attempt 3, we use U equals ln X, and that actually worked. Okay? And so the remaining X dx, we suppose that to be dV. And that's the technique. Please remember the rule, Liat, and it will make your life easy. And let's try few more. Let's try all the way. Let's go all the way down. Okay, example 6. In example 6, you see here, this can be written as 1 times ln x dx, right? We can write that. So 1 can be considered as your algebraic function, and this is your logarithmic function. So in the Liat rule, which comes first? L comes first, right? So therefore, for this question, you suppose U to be ln x. And so the remaining dV is remaining. 1 times dx is your dV. And I want you to complete that now using the IBP. Right now, okay? So in this example, we have said that U equals ln x. We choose dV to be remaining term 1 dx. So you find the derivative on this side. So du over dx is 1 over x, so du equals 1 over x dx. And you need to find the integration on this side. So integration of dv equals integration of dx. And that's going to give me v equals x. So substituting the value here in the formula, integration u is ln x, dv is dx, equals u is ln x, v is x, minus integration v is x, du is 1 over x dx. So that gives me x ln x minus x cancel out, you simply get dx, so which is actually x ln x minus x. Okay, integration of dx is x, and the constant of integration c. So later, now from now onwards, we will use this as a formula. So ln x dx equals x ln x minus x plus c. Now let's check whether this answer is right or wrong, okay? You can check it by yourself. So checking. If I do the derivative of x ln x minus x plus c, what do I get? Okay, if I find the derivative using the product rule, okay, product rule, so copy this derivative of first, which is 1 over x, plus derivative of this and ln x minus 1 plus c. So this cancel out. You're going to get 1 plus ln x minus 1 plus c. This cancel out. Well, this c will be 0, by the way. So you're going to get ln x, and that's what it is, right? Okay, our answer is correct. So you can check your answers by differentiating. I think we have been doing that right from the beginning. Any questions so far? Okay. All right, so let's try example 3. Okay, so example 3, x to the power 4 e to the x dx. Now in this case, use the rule, Liat rule. So this is your algebraic function and this is your exponential function. Write down the rule, Liat. So which one comes first, A or E? Of course, A comes first in that rule. Okay, A comes before E. So this will be our U. So U is, in this case, let U equals x to the power 4. So the remaining will be dV. So the dV is e to the x dx. Now, you find the derivative on this side, find the integration on this side. So, okay, find the derivative, which is du over dx is 4x cubed. Find the integration, which is integration of dv equals integration this. Now, this gonna give you du equals 4x cubed dx, and this will be b equals e to the x. Now, let us substitute the value in IBP. So the formula is integration u dot dv equals ub minus integration v du. So if I substitute the value, u is x to the power 4, dv is e to the x dx equals u is x to the power 4, v is e to the x minus integration v du. So integration v is e to the x, du is this, so 4x cubed dx, which is x to the power 4 e to the x minus 4 integration x cubed e to the x dx. Okay, notice that we started with power 4 here. Now, after one time of using IBP, what we got here is that the resulting integral has just one power less than the original one. Okay, one power less, 3. So it means in order to evaluate this integral, we have to do the, we have to repeat the integration by parts 3 more times. Do you agree with me? We already use integration by parts. What we are able to achieve here so far is that it just reduced the power of x by 1. Everything's the same. So we need to use integration by parts 3 times. So imagine if I give you a function, let's say x to the power 10, for example, e to the x dx. So you have to use integration by parts 10 times, right? That's too much time consuming. I know that, you guys are busy people and you don't want to spend so much time just, working with this ugly math problem. Just in case if I give you x power 20 ex, so it will take almost like 1 hour or even more than that, maybe 2 hours. So it means we need to develop some efficient way of doing this. Does that make sense? Okay, I'm not going to do this 3 times. So to complete, okay, to evaluate the given integral, it seems that we need to use IBP again and again for another another 3 more times, which is, this is really time consuming. Okay, here is the nice method. Here is a nice method to evaluate the integral for this kind of, to evaluate for this kind of integral. Okay, let's see. All right, so this is the method that we're going to use now. I call it table method. Okay, so the table method. And this method works pretty much for all the integral. So in tabular method, what we do is, okay guys, one thing, if you want to use the IBP for 3 more times and find the answer, I'm okay with that. I don't have any problem. The only thing is it takes a lot of time. Okay, I don't want you to spend so much time for this little one problem. So therefore we are trying to come up with a better method which will save our time, which is more efficient. Okay, that's the goal here. In tabular method, what you do is you make a table. I'll write that sign, and here I'll write u, and remember for u what we did is we found the derivative of u, right? Derivative. And here I'll write dv, which means integration. So this, for dv we did the integration, so all we need to do this integration. So instead of dv, I simply write v, if you don't mind. Okay, so this means the same thing. I don't write that dv. I can write v only. So u is, we already know, using the same rule, we know that u is our x power 4, and v is our e to the x. E to the x dx. If I write dv, this will be e to the x dx. You can write that if you like. But remember, we already know we have to do the integration, so you don't have to write that dx. Simply write v and e to the x. That's fine. Okay. All you need to do is keep on finding the derivative on this column. So the derivative of x to the power 4 is 4x cubed. Any question? Derivative of 4x cubed is 12x squared. Keep on finding the derivative. Now 24x, now 24, now 0, and you stop there, because once you get 0, and no matter how many times you find the derivative, it will always be 0. So you stop there. Okay, so half job done actually. Now on this side, you find the integration. So integration of e to the x is e to the x. Integration of e to the x is e to the x, e to the x, e to the x, and e to the x. Now, one thing we need to remember, sign is, always start with positive, negative, its sign will alternate. That is the technique that you need to remember, okay? Positive, negative here, positive, negative. Just write down. So we are done actually. You already found the integration for this. All you need to do is write this in a nice way. Okay, how do you write that? Well, always start with this one goes there. Okay, this guy goes one step down. Just do this. It always go one step down, and all the, the bottom part will go with the bottom part. So the last one will go with last. Now let me write down the integration. So our answer is x to the power 4 e to the x dx is going to be, you just multiply that. So we got x power 4 e to the x. Okay, I multiply the first one. Remember the sign. For the first one, the sign is positive. Now let's work with second one. So the second one, the sign is negative. So the negative sign, and so multiply this with that. So multiply these two guys. So 4x cubed e to the x is your second term. Now, when you go to the third, row, so that will be positive 1. So 1 times 12x square is 12x square, and then go one step down there, e to the x. And now fourth. So when you go to the fourth row, it will be negative 1 times 24x is 24x. And this 24 goes there, which is e to the x. Just multiply them. And then the next one will be positive 1 times 24 is 24. And e to the x. And the last one always come with integration. So this integration 0 times e to the x dx. But 0 times anything will be 0, so I don't have to write that. So simply 0, the last one will be 0 plus c. That is your answer, done. Okay, so it saves a lot of time actually. So we can apply this rule for the previous questions that we have just done. All the example we can do this way if you like. Any question? So let's try one more example using this tabular method. Okay, here is the question. X to the power 4 cos x dx. Now, this is your algebraic function, and this is your trigonometric function. Tell me which one is u and which one is v, or dv for that matter. Write this in your chat box. Okay, excellent, guys. You already got the idea, because once you know that this is your algebraic function, this is your trigonometric functions, and you know the rule Liat. So in this, algebraic function comes first, then trigonometric function. Therefore, your u will be x to the power 4, and dv is cos x dx. And if you use the method, the first method that we did earlier, you're gonna apply IBP 4 times, which is really time consuming. So we're gonna use the tabular method, okay? So here we want to use tabular method. In the tabular method, so you make a table. First one will be sine. And here your u, meaning you have to do the derivative here, okay? So u means derivative, and v is integration. That's what we want to do. Okay, try to complete it by yourself and let me know the answer. So here your u is x to the power 4 and your v is cosine x. And so we need to find the derivative until we get 0. So that means this will be 4x cubed and another one will be 12x squared, 24x, 24 and 0, and we'll stop there. I know that some of you have already calculated, but let me just complete for those who need you know, extra help. So we need to find the integration here. So integration of cosine x is sine x. Integration of sine x is negative cosine x. Integration of negative cosine x will be negative will be negative. Integration of cosine x is sine x. Integration of sine x is negative cos x. So negative will be positive. So I can simply write positive cosine x. And so, and the last one will be sine x. Integration on this side. Sine, okay, always start with positive 1, negative 1, positive 1, negative 1, positive 1, negative 1. And so, you know, it is done almost. Now our job is to write them in a nice way, right? Always start with, it goes like that. Okay, this guy goes one step down and the last will go with last. So your answer is going to be x to the power 4 cos x dx is going to be x to the power 4 sine x, positive, okay, the first one with positive, the second one start with that, negative 4x cubed times negative cos x. So that's going to be this, and then plus 12x squared times negative sine x minus 24x times cosine x plus 24 times sine x plus integration of 0 times sine x. So the last term you keep integration, but since 0 times anything will be 0, I don't want to put the integration there. I simply write 0 plus c at the end. So that's it. So it looks a little ugly, so you can write it nicely now, which is x to the power 4 sine x minus negative positive 4x cubed cosine x minus 12x squared sine x minus 24x cos x plus 24 sine x plus c. Done. Now, just for fun, let's try the one that we did earlier using the integration by part first method. Let's try that just in case if it works or not. This problem that I'm talking about, this one, let's try this using this method just for fun, okay? Example 2 by tabular method. So you already know which one is u and which one is v, because this one is your algebraic and this is your logarithmic in the Liat rule. We already discussed that. L comes first, so we make a table. Sign there, and here u, which is derivative, and v, which is integration. And so u is ln x and v is x. So for for these kind of problem, the tabular method doesn't work as nicely as we saw in the previous example, but still we can use. Okay, but still we can use. As you can see, derivative of ln x is 1 over x. Now, if you keep on finding the derivative, it is not going to be 0, never ever. Okay, you can actually find the derivative throughout your life and still you are not going to get 0. But notice one thing. Earlier, it was a logarithmic function. Now this is no more logarithmic functions. Okay, it's just a simple fraction 1 over x, algebraic function. It changes its type. And when the function does not get 0 in differentiation, but when it changes its type, and you can stop there. So we are done almost. Let me repeat that. First, try to get 0 by differentiation. But if you think that it will never going to be 0, then look at the situations, whether the function changes its type or whether the function repeats by itself. So there are only 3 conditions that you need to look at. One is when the function becomes 0 in the process of derivative. If that is not the case, then check whether the function type changes from one type to another. Here, logarithmic function changes into another type, algebraic. And sometimes it will not change, the function will not change, but it will repeat by itself, exact same function. And in that case, you will stop there. So we'll see one example later. Okay, so now we will stop there because we already noticed that the function changes its type. Now, all you need to do is find the integration for that x, which is x squared over 2. So now your sign is +1, -1, and you are almost done. So go from here to there, and the last will go with last one. Okay, keep that in mind. So your integration x ln x dx is going to be, so the first one is x squared over 2 ln x. Positive ln x times x squared over 2 is this. Now -1, so negative. Remember, I told you that the last term will always come with integration sign. But in the previous example, there was 0. So I didn't write the integration sign, but keep in mind. So this one is 1 over x times x squared over 2 dx. Okay, that's it. Equals, this is going to be x squared over 2 ln x minus, if you work it out, you're going to get x dx. So that's going to be x squared over 2 ln x minus half x squared over 2 plus c. That's it. And this is what we got earlier. Okay. You can write this nicely, maybe x squared over 4. Okay. And there is one more type. If you have any question, let me know. Otherwise, let's try one more, which is example 5. Integrand that never go away. For example, so I want you to try this on your own. I'll be doing this, but you will be working on your own, okay? So this is your exponential function, and this is your trigonometric functions. Now, use the Liat rule. In Liat, T comes first. T comes before E. Therefore, your U will be this. And your V, dV is e to the negative x dx. So guys, if you want to use the integration by parts, the first method, you have to use quite a few times. So that's time consuming. So I'm going to use, to make life easy, I'm going to use the tabular method for this again. In tabular method, basically tabular method is also integration by parts. The only thing is that we put all the things in a very systematic way in a table. That's why, you know, it's making our life easy. So let us make a table. So derivative of cosine. Okay, derivative of cosine 2x is going to be negative sine 2x times 2. So you're going to get negative 2 sine 2x. Now remember, no matter how many times you differentiate, this function is not going to be 0. Now the question is, when do we stop differentiating? Well, whenever you see the function repeats, exact same function repeats, then you can stop there. So for example, if you find the derivative again, okay, derivative again, which is derivative of sine 2x, so you're going to get, you know, cosine 2x times 2. So this derivative will be this negative 2 sine 2x. So we want to find the derivative of this guy, which will give me negative 2 cosine 2x, and then derivative of sine is cos, and derivative of 2x is 2. So that's going to give me negative 4 cos 2x. So negative 4 cos 2x. You see, cos 2x was there and cos 2x is here. So the function, same function, exact same function repeats. Now you can stop there. Okay, no more derivative. Because if you try to make it 0, it will never be 0. You can differentiate throughout your life, still you don't get 0. So as soon as you see that the function repeats by itself, then you stop there. Now we need to find the integration on this table. So it's going to be e to the negative x. So negative, because integration of e to the negative x dx is, we know that it's going to be e negative x over negative 1. So, and then if you find the integration of this guy will be negative e negative x. So that's going to be positive. So that's what it will be. I trust that everybody know how to find the, you know, integration of this simple function. Okay, the sign will be, this sign will be start with positive, negative, positive. So you're done. That's what the, you know, integration by parts is. Now let us write down nice way. Okay, So integration, our question is, let me just copy the question, e to the negative x cos 2x dx equals, last will go with last, so equals positive 1 times cos 2x is cos 2x times negative e to the x will be negative e to the x, negative x cos 2x. Okay, the first line is done. Now the second line, you go this way, that way, you go this way. So negative times negative is positive, and positive times negative will be negative 2e to the negative x sine 2x. Okay, and the last one will be positive times negative will be negative 4 e to the negative x cos 2x. Remember, this guy will be always with integration. Okay, last term will come with integration. Okay, so are we done? No, because you see on the right hand side there is still integration, but how do we find the integration of this? Well, we don't know. We tried, and it turns out that we pretty much got the same original function, right? Now, use high school algebra, common sense in high school algebra now. So what I want to do is all the term that has an integration sign, I will keep it on the right hand side, because on the left hand side, we cannot have that. So on the right hand side, if I bring this, I'm going to get integration e to the negative x cos 2x dx plus 4e to the, because this negative, when you change to the other side, will be positive, e to the negative x cos 2x dx. Okay, I forgot to write the dx there, equals the term that doesn't have the integration sign, write it down, so which is negative e negative x cos 2x minus 2e negative x 2x. Okay. All right. Now, you see, they are the same thing. This is one, it's like 1 orange plus 4 orange, because they are like terms, right? So you can add them up. So you're going to get 5 times integration e raised to power negative cos 2x dx equals negative, you can take that negative common if you like, but you don't have to, e to the negative x cos 2x minus 2 e to the x cos 2x. Now I want just this, because that's the value, that's the integral that I need to evaluate. I don't want 5 there. So what should I do? Use your high school algebra. Just divide both sides by 5, okay? Dividing both sides by 5. So we get e to the integration e to the negative x cos 2x dx equals negative e to the negative x cos 2x minus 2e negative x cos 2x divided by 5. Right? That's the answer. But remember, we always need to write the constant of integration at the end. So I'm writing c there. So this is my answer. So integration of this guy is this. All we need to do is we need to evaluate this integral. Look at the question. This is the original questions, which means this is our integral. We evaluate it. Okay? Any question? Notice that in all the examples that we have done, when we use the tabular method, what we notice is that sometimes if we differentiate that you will be getting 0. That's a really nice application of tabular method. But sometimes when you differentiate, it will not change into 0. Sometimes it will change from one function type into another type. For example, here, let me just recap. So which one is that? Okay, here. For this question, example 2, when we differentiate, the function changes. It was algebra, the logarithmic function, and when we differentiate, it changes into different type of function. It is no more logarithm. So if that is the case, you can stop there. So that's the second, second thing that you need to remember. And sometimes the function will not change, but it will just repeat exact same function. For example, in that example of 5, here we started with cos 2x and we did the differentiation. The function type did not change. It was trigonometric function. It is also trigonometric function. But we noticed that after another differentiation, we got exact same term there, exact same factor. So in that case, you can just stop and work it out. So these are the 3 conditions you need to remember if you want to use the tabular method. If you want to use the integration by parts, then yes, you have to use like 2 or 3 times. It's really time consuming, okay? Again, these examples are not given in your textbook, but you need to know. And the last one, so definite integral using IBP. Let's try this. We have done all the examples with indefinite integral. This is the definite integral that we want to try, okay? So you can use integration by parts, or you can use a tabular method, and I want you to calculate what is the integration of that, okay? Consider 6x squared ln x dx. Now, you can come up with what factors will be u, what factors will be dv, and then you can put this in your table. Sine. Okay, forget about the definite integral at this time. Just evaluate the indefinite integral. Here your u, which means derivative, and here v, which means integration. And so try to complete and let me know what is your integration, okay? Therefore, integration of 6x squared ln x dx equals, let me know what is this answer, and then we'll find what is this 1 to 4, 6x squared ln x dx, and I'll tell you how to do this at the end. So the integration is this. Now remember, this one is definite integral. So what I want to do here is that, so for definite integral, so we'll get 2x cubed ln x minus, let me copy that, 2 over 3x cubed plus c. We don't need that c. So this is from 1 to 4. And using your calculator, substituting the value, you're going to get 2 times 4 cubed ln x minus 2 times 3, 4 cubed. You can take that x cubed common if you like. And minus 2, 1 cubed ln 1 minus 2 over 3, 1 square. And use your calculator and let me know the answer. Okay, so just type in these numbers in your calculator and whatever you'll get, that will be your answer. Now, we have done so many examples using integration by parts. In the same manner, we can actually use integration by parts to solve, many other problems, many other type of function, like here, for example, example 8, we can use integration by parts, but there is a better way. We can use formula directly as well. I'm going to provide you the table of formula, and using that formula, we'll solve this example 8, okay? Look at the formula in your canvas, in your handout. I think the handout that I uploaded in Canvas has all the table. Okay, look at the table, look at your handout, and tell me which formula is closely resembles with this question. So we have a question 3 you can write outside, no problem there. So you can write 1 over x squared minus 4 dx, or you can write 3 dx over x squared minus 2 squared. So now look at the table, look at the list of formula that I have provided in Canvas, and tell me which one is closely related to this. I have actually wrote it here. Right, so yeah, in the table it's a different one. I think yes, in the table that I provided in Canvas, that is, let me not write this 1 and 2. So the first formula here, but in the table, the order is different. So this one is, using the formula, what we can write is that you can just use the formula and you can write 1 over 2 times a is 2. So 2 times 2, well, 3 is there, by the way. Let me write 3 as it is. So we're going to get 1 over 2a ln x minus a is 2. When you compare this with, compare this with dx over x squared minus a squared, if you compare these two guys, so you're going to get a equals 2. So x minus 2 over x plus 2 plus c, done. That is the answer. If you want to write this in a nice way, you're going to get 3 over 4 ln x minus 2 over x plus 2 plus c. Sometimes using formula is pretty straightforward, and if the question is a little bit complicated to evaluate using the other method like substitution rule or integration by parts, then I will give you the formula, list of formula, and you just apply that formula. No issue there. Now let's try example 9 quickly. Tell me which one resembles this closely to the formula number 1, 2, 3 in the list provided in Canvas. I can write this nicely like this. Let me just write it down. X squared, I'll have 1 over x cubed squared plus 3 square. I can write this way. Now tell me which one resembles very closely to this. So it nicely resembles with the formula in the list, formula number 4. Let me just copy that formula, okay? So the formula is this: integration dx over square root x square minus a square, right? That's what it is. So the formula is this. It will be ln x plus square root x square plus a square plus c. Not plus, minus, or plus or minus. Plus, yeah. This is the formula. Okay, this formula will be provided you in the exam if there is any questions of this type. Now your answer is going to be, using the formula, your answer is going to be, you can simply write, oh, by the way, hold a second here. So this one is let u equals x square, then this becomes, your du becomes x square or x cube. This should be your u. Sorry, u equal x cube. So your du over dx becomes 3x square. So it gives me du equals, du over 3 equals x square dx. So I can substitute that x square dx. I can actually write this x square dx as du. So that's going to give me du over, this will be u square plus 3 square. Okay, so in order to change this, we need to use substitution rule. This one is a little tricky, guys. Okay, now using formula, you can say that the integration is ln, your x here is u plus integration u square plus a square plus c, but you know, u is, a means 3, u square plus 3 square. So your answer is ln u is, what is u? X cube. Oh, hold a second, I forgot to write this 1 over 3. So this x square dx is du over 3. I can write that 1 over 3 there. So it will be 1 over 3, 1 over 3, x, u means x cube, substituting the value back, plus square root, u means x cube square plus 3 square plus c. That's it. If you want to write this nicely, you're going to get 1 over 3 ln x cube plus square root x power 6 plus 9 plus c. All right. So we are done with this concept of integration by parts. So this section is done. It's not easy. There are lots of things going on. You need a lot of practice. Okay, guys? Okay, guys. So example 10, like I said earlier, we want to do this by two methods, one integration by parts, another by substitution. And one of the question, very important question, is that if you want to use IBP, so both are algebraic functions. So which one will be u and which one will be v? So remember what we discussed earlier at the beginning of the class is that we suppose u, in general, we suppose u such that when we do the derivative, it will become simpler and simpler. So if you suppose u to be x, and if you find the derivative du over dx, it becomes simpler. right? If you suppose this x to be dv, for example, dv is x dx, what happens here? So dv, I mean, if you do the integration, it's going to get bigger and bigger, right? So x squared over 2 if you do the integration. So I think the easiest, the life will be easy if you suppose u to be x. So let us suppose that u is x. Let us use the table here. So sign here u and dv here. So this side derivative, this side integration. And I want you to complete that, both part A and part B yourself. And then once you get the answer, you will notice that the answer look different, okay? Part A and part B, using these two different methods, you will notice that the answer look completely different. And now I want you to talk about that and tell me why they look different, whether they're, you know, the same or not, and which method is better in order to solve this particular problem. Okay, these are the questions you will be thinking.